Hello everyone, it's November 27th. I'm still coughing. Damn. It's bad. The coughing's still happening. Alright, anyway. That's not the point for today. It usually gets worse the later it is to the night. Alright, what do we have? 5 players with 0 or 1 losses. Given an integer array, matches where matches I equals winner I, loser I, indicate that the player winner I defeated loser I in a match. Return a list of answer of size 2. 0 is a answer 0 is a list of all players that have not lost any match. Oh my god. 1 is the player have lost exactly 1 match. The values in the 2 list shall be returned in increasing order. Okay. Matches I is a winner I and loser I. No indicate that the winner I defeated player loser I in a match. List of all players that have not lost any matches. And then the other one is list of players that have lost exactly 1 match. Okay. Should consider players that have played at least 1 match. Test key will be generated. No 2 matches will have the same outcome. Okay, 1 win over 3. 2 win over 3. 3 win over 6, but I have 2 losses already. So what we're looking at, we just need to track the number of times a player has a win and a player has losses. So what I can do, I can have 2 counters. 1 counter for the number of wins. 1 counter for the number of losses. And then what we're gonna do is we just keep track of the total number of wins and losses. And then we will get the ones having no losses. What if a player has exactly have lost exactly 1 and they have not lost it? Oh, okay. There will be no overlap, so that's good. God, it's not good. Oh, I am not feeling good. Sometimes in my current situation, when I catch a cold, I don't have, let's say, a headache or even runny nose. It's usually just coughing. And it can get bad, like what I'm having right now. Oh. Anyway, I have 2 counters. So I have losses, right? So LC is the losses counter, and have not lost any match. Oh, 0 loss and 1 loss. Oh, that should be it. And it has to play at least 1 match. That's fine. Winner, loser in matches. Right? Oh, but you need the people who have you need a winner. You need a WC. Unfortunately. And then WCW plus equal 1. WCL plus equal 1. Right? And then we can say have player has not lost any matches. Anyway, rest is equal to this and this, right? Player has not lost any match. that will be for player in win, right? Actually, that's not true. Could be in losses as well. Like a player can keep winning but never lose any match, right? Can never lose any match. So what shall we do? Ah, I see. So what is C? It's winning, right? And then the losing 0, right? This one losing plus equal 1, but winning that shall do. Then we do that, we can just go through in the winnings, right? So if no, just the losing match, if it's 0, but at least I played one, then we can say res 0.append player, right? And then elif it has to be winning must be larger than 0 and losing is 1, and then lost exactly 1 match, which means then just the losing, right? Then it'll be easier. Losing is exactly 1 match, then res 1 player. And then we say res 0 dot sort res 1 dot sort, then return res. Matches, find winners. Okay. Looks good. Trying to see if it's possible to. Nah, I don't think so. I think that's a good one to deal with. Oh, now where's my submit button? Oh no. Oh, I got lucky. I thought I'm gonna miss something. Oh, maybe there's no difference in the test case and for this one. Doesn't seem to be to me. Just very straightforward. Two, 5. Use counter. Wow. I could call it all in log n because we have the sort. Okay. 127. 127, yeah, it's exactly the same. Oh, set. That, well, that's fine. This is actually pretty smart. I actually like this one. Is this the solution? Yep, that is the solution. One seemed to be enough. Oh yeah. One should be enough. Because if a player's loss is 0, if I play and the loss is 0, yeah, one should be enough. Oh God. Update. I only need one counter. Yep. Okay, now we're done with this. I have a proposal to do because it's very fast, right? So what we can do is maybe we go into a contest and we can do a virtual one. Which one you want to do? It didn't tell you if something you have done, right? I don't know. I mean, I haven't done quite a lot of them. What we can do is, we just okay. Let's try this. We're doing a virtual contest of, this is the last week. Okay, let's try this. Oh, actually, I'm not ready yet. You can say virtual contest. What is this one? Virtual contest what? 321. Okay. Nah, just don't CD into it. Just copy and it's gonna be virtual contest 2 code 2485. Alright, 2485. Yes. Alright, let's take a look at this one. What do we want? Given a positive integer n, find the pivot x such that sum of all elements between 1 and x inclusively equals the sum of all elements between x and I. X and n inclusively. Return the pivot index x. If no such integer exists, return -1. So given n, All right, I want find a pivot integer x such that 1 to x equal to sum of x to n. Okay, so if it doesn't exist, return -1. So we have, we want a 1 plus 2 plus 2x equals x plus plus 2n. Now x has to be in between, right? 1 to n, because if it's on the outside, 1, 2x is always going to be larger, so x has to be in between. Okay, so we can say on the left side is x plus 1 divided by 2. The right side is x plus n minus x plus 1 plus 2. Okay, divided by 2, get rid of it. X squared plus x equals oh my god. Oh, we can say n minus x, so it's n 1 plus x, n squared minus x squared plus n plus x. Okay, plus x, get rid of, so we have 2x squared equals n squared plus n. So x squared equals n squared plus n divided by 2. So we just need to see if this one works. So if n equals 8, then, wow, that's actually n times n plus 1 divided by 2. So it's 8 times 9 divided by 2. Oh, it's always going to be an integer, but it has to be a perfect integer, right? So what we're going to do, put this one here. Okay, and then we say t equals n times n plus 1. Oof. P and R. I'm going to say div mod 2. If r is equal to 0 and math.qrt r, we should say this one int this squared is equal to r, should be p, right? Come on, no, it should be q, quotient. Okay, so this one if it's equal, then we return shit. Oh my god. Oh no, it's guaranteed. I don't know why I do this. It's guaranteed to be divisible. My bad. Then we just need to say if this, we return q, right? Otherwise we return -1. Okay. But am I slow? I am very slow in this one. But it's okay. It's okay. Goal is just to get past the first 3, and we might not even want to. I might not even want to do the last one. At least not today. Pivot. Ah, dude, man. It's QRT cute. Cute. No, it's this one. Oh, there we go. Okay, first one. Okay. Use math. Okay, next one. This one should be back to contest. Next one. Append characters to string to make subsequence. So you're given 2 string s and t, lowercase letters, return the minimum number of characters that need to be appended to the end of s so that t becomes a subsequence of s. Subsequence has to be contiguous. Oh no, hold on. That's subarray. Subsequence does not have to be contiguous. All right, so coaching and encoding, we want to say minimum number of characters that need to be appended to the end of S such that DING, right? Yeah, you have to do DING for this. Such that T becomes a subsequence of S. Ooh, T becomes a subsequence of S. That's an interesting thing to think about. T becomes a subsequence to S. Okay. If I know the maximum matching between the two, yeah, if I know, let's say the maximum, because I'm adding something to the end, right? Which means if T can be matched completely, then I only need to add 0. If T can only match, let's say like in this first example, we can only match CO, right? That's what we can match. All right, so now the question is, how do I find the maximum match between the two? Longest common subsequence. Right? Not exactly. I won't say the longest common subsequence, but it's just we can match, and it doesn't match. I'm trying to find the next match. Subsequences doesn't really matter, so we just want the earliest match of T in S, right? So the first match done, we move on to the next one. Yeah, and then we do this and try to match as much as we can, and then I think that shall work. That is 6. Yeah, I think this shall work. Okay. So what you're thinking? We have 2 pointers, okay? 2 pointers. And I equals j equals 0. Actually no. I don't have to change S. Say if letter equal to T, no, TJ, J plus equal 1, else we just go searching the equal, then we move forward. You know what? Okay, so once we're done, we can just return, so J, we match 0, 1, 2, 3, so everything we match, then should be the len T minus J. Alright, should be J plus 1, so it should be minus 1. Because these are the one that cannot be matched. Let's see. I have no idea. I'm just trying, you know? Call it a hint, not a hunch, that I think is correct. This is, what, a greedy? I think it's just analysis, S and T, append, S and T. Oopsie doozy. just say if j is equal to len t, means we have done, not return. No, not return, break. Ooh, that is not what I had expected. Oh, really? That's unfortunate. 2, 0, 1. We're landing at the 1. Oh, we land at the 1. That's alright. That's my bad. We'll land at the 1 that's been unmatched. There we go. Okay, this one's done. Try to match as much t inness as possible. Then the number of letters not matched in t must be appended to s. I actually don't have the time. Oh my god. Next one, remove nodes from linked list. You're given a head. Remove every node which has a node with a strictly greater value anywhere to the right side of it. Return the head. Remove every node which has a node with a strictly greater value anywhere to the right. Okay. Okie dokie. Okie dokie. I mean, I can turn that into a heap, right? If I turn that into a heap, then we can just check every index. If the index is, you know, if it's a small index, it's not at the end, then it has to be removed, right? Hey, we are simulating a contest, so that's how I'm gonna do in a contest. Sure, you can count on that. That's what I'm gonna do. Just for context's sake. I probably will try to find another solution. Oh my god, we can do a solution too, that's fine. Okay. So we say list. Oh, we can just do heap. Oh, heap. Not collection, just import. Okay, so we have a heap. And then we say while head, right? Heap q dot heap. Oh, I need index. Heap q dot heap push heap push two values head dot val and I head equals head dot next. Okay, and equals len heap. Then we say while heap. We just need to know which one needs to be removed. And the ones now removed. Oh, hold on. It has to follow the same order, right? Oh, oopsie doozy. Has to follow the same order. So now what? Monotonic array. 5, 2, 13. Then they're all gone. Because I have something bigger. Alright. 3, 8. Yeah, it's a monotonic array. It's a monotonic decreasing array. Okay, so it's not a heap. It's a stack. Oh my god. Well, head val equals head of val. Okay. So while stack and stack minus 1. If this one is smaller than okay, if it's smaller than val, then stack dot pop. Then stack dot append val. And then head goes ahead next. Then when I say res head equals if stack, if not stack. None, right? Then we say res head is equal to, we'll list a node, val equals stack 0. Then we say node equals not node equals res head. Then for I can do a dummy. So now we equal to dummy, and then for v in stack node. Okay, node dot val, okay, equals v. Node on next equals list node. Return dummy dot head. Okay, try this. Oh, I'm not testing this one. None type line node dot val. Yeah, why do you do that? Next equals head. Wait, what? Dummy dot head. Yeah, gotta be kidding me. Okay. That's dumb. Huh. How? How is that not right? Where does 0 come from? What? Oh, I think I know because I do that. Holy crap. You know what? Okay. That's not right. Let's take a look at the stack. Stack is correct. I said node is dummy. Node on next equals. Oh, I forgot to shoot. Oh, that's my bad. That is stupid. Ooh. Ooh, that is stupid. All right, this might be right. Oof, got it. But like I said, this is more this is more or less a cheating method, because we basically turn the linked list into a monotonic decreasing array, and then turn the array back to linked list. Oh, and but space complexity is also ON. So that's the issue. Now, can we just go directly? I guess we can. It's just a monotonic array, right? So if we have 2 pointers, oh, how'd you do pop? Damn. How do you do pop? Like, ba, ba, boom. This is larger than this, so I need to remove this, right? And then how do I get my pointer back here? I don't know, man. I have no idea. Okay, this one, okay, it's worth to go to discuss to see what other people's idea. We can do recursion. Can do reverse list versus stack. Monotonic, yeah, I'm using monotonic, but kind of don't like it. Recursion. Let me think. Recursion. So for each one, I try to see, okay, if there is anything larger than me for the remainder. If there is, maybe it'll work. Yeah, and I'll delete myself, right? So I say, for anyone, I say I want to find this if there's anything larger than my value, which is right larger than this. Okay, that will pass in the target. Larger than this. Wait, hold on. If I'm smaller than the previous one. Wait, hold on. What? Oh, is that what they say? You go back to front. This one definitely is. This one's definitely good. then we see this one, right? This is larger than this has to be removed. Then we go here. And this one will check. Check what? If this one's removed, which means something's bigger than that. So I just need to see if something's bigger than me. So if something is removed, that must be bigger, right? Because it's a monotonic decreasing, all right? So I only need to compare to, oh, damn, that is correct. I only need to compare to the one right next to me, right after me, because of monotonic decreasing. If this one is smaller than me, everybody is smaller than me. Oh, that is the solution. Damn, man. Very smart. This is lead to 15 solution. Well, the result is a linked list with monotonic decreasing so if we start processing at the end of the list, right? If we process the linked list from right to left, it is guaranteed that each time a node is under consideration, all nodes to its right must have formed the monotonic decreasing property. Thus, the current node only needs to be compared to the node to its next to determine whether it itself shall be removed, right? Okay, so this can be done, achieved using recursion. Oh, the def helper node is my style. Can return a what? Okay. You can say if not node, right? Then we return none. If there is a node, right? What do? If there is a node, we want to know its next. So what we want to do is we can get helper node.next. This is to rearrange, right? This is to rearrange the next one, and then I can say next node is equal to this, right? And then we say if node.val is larger than next node. Oh, and also next node has to exist. If next node and this is larger than this val, actually larger equal to, because we can equal. In that case, then we're gonna say node.next equals next node, and then we'll return node, right? Otherwise, if it's not, if it's a none, right? Otherwise, next node has something, but the current node is smaller. Okay. If the current node is smaller, then the current node needs to be deleted, which just means we're gonna return next node. Okay, so with that in mind, I can just return helper. Man, you're talking of, if you kind of think about things in this way. An important realization is we can do, like a reverse by simply doing recursion. Okay, let's see. 2,252. Anyway. Okay. So, yeah, not too shabby, right? I think we start like 13. It's about half an hour. Not really pushing. Yeah, half an hour. Yeah, 3.5 an hour. Not really in the mood of doing this one today, so we will handle it tomorrow. We can take a look, all right? We don't have to solve it. And then you can start thinking when I'm in bed. Given an array nums of size n consisting of distinct integers from 1 to n, okay? Positive integer k. Return the number of non-empty subarrays that have a median equal to k. Ooh, interesting. One, two, three, four. Huh? Oh, the median is the left middle value. So we're gonna sort it. Oh, we cannot sort it because it's asking for sub array. Interesting. This is an interesting question. Oh, wow. Well, you know what this reminds me of? Segment tree. Right? I need a range. If you give me a range, can you get the median immediately for this range? That's what I thought. And every value is unique. Right? Yeah, every value is unique. So if I know it's actually no. Wait, hold on. If I know every single one, then every twos, I will know, right? I will know because I know every single one. So if I know the min and max, right? They're given a subarray. If I know its current median and I know its min and max, and I add a new one, well, you already know which direction the thing's getting nudged. Oh my god. My cats are collaborating, trying to get into the cabinet. All right, I'll think about it. I'll see you guys tomorrow.